right? Right, so conjugate, their conjugate is 1 plus 4i. So for this one, you just need the top and bottom times i, so it became I squared, right? So just times I. So right now the denominator became -1. All right, here became 3i minus 2i squared, right? 2i squared became -1, became 2. That's 2 plus 3i, right? Over 2, over -1, over -1, right? For this part, their conjugate is what? The conjugate is 5 plus 3i, right? 5 plus 3i. So here became 25 minus 9i squared. So actually 9i squared is became positive 9, right? So it became 34, right? So that's relatively easy for you guys. I think it is just do additional kinds of information. Just I squared change into -1, right? Any question to this part?
No.
Yeah, unmute yourself, answer a question, okay?
No.
All right, that's great. Good to hear. Good to hear. Okay, let's move on. Next one. What should we do next? So I give some additional information here to let you guys practice the complex calculation, especially the divide, right? And after that, we know how to graphing complex number. So complex number like give these kinds of expressions similar to when we do the XY planet is 3 and 4. So you can find the dot. See, -4 plus I here actually equals to -4 and 2. So you can just see actually they have the real x-size and the imaginary x-size, right? So this is the real part and this is the imaginary part. So similarly, like this is the real part, this is the imaginary part. So you can gotta say -4 plus 2i equal here, my number here. And 3 plus 0i is right here, right? And 0 plus 4i, 0 plus 4i, 0, 4, 0, 4 here. So each dot have their own positions, like they have like a complex number. Give you any complex number, they have their own spot. You can find these numbers. So this is just like find the dot in x, y, right? Earlier we learned quadratic functions. Right now we can find a number, each of the dot. So give you any complex number, you can find the dot in this graphing process. And after that, I also goes to say, when we do addition numbers, something like this number do the addition, normally we can do quickly, you can find out, say real part plus together here became -1, and imaginary part plus together became 4i, right? So we can see 3 plus 3i is right here, -4 plus I is right here. When they plus together became -1 plus 4i. So you can see that is got right here. What's their relationship? It looks like in a parallel going to the quadratic. I mean, this two is parallel, this two is parallel, and became the cross. I mean hexagonal point. Just like a force, you push one force to this side and push another force to this side. They exactly equals to the force pushed in this way. All right. So that's the interesting part here. We will use this part in physics in many different aspects. Especially when you go to the middle school, you learn physics. A lot of basic information is based on this one to describe. Math is service for the physics. A lot of physics cannot be explained, math became the tool to help to explain this one. All right, so we also ask you guys try to find out what kinds of these things here. Okay, so actually I also draw this one as well. Ask you guys do this one. Subtract two complex numbers. Complex two numbers. You can see here. Complex number means this one minus this one. So initially is is this number, complex number, minus this number. So initially this number is negative 1 4i. Negative 1 4i is right here, right? Minus here, minus this number became negative 3 3i. Negative 3 3i is right here. So combine these two, you can see you got this number here became 4, negative 4 plus I, negative 4 plus I. So complex number we will use in physics. I like to give some examples in the physics area. That's about electric. How do you calculate electric cases? I think I can bring up one of my my complex number example here. This one. Let me share this one. I'm sorry, I maybe didn't see one here. Let me go to here. Yep. Make it bigger. Can you guys see my screen here?
Yeah.
Oh yeah. Maybe you guys already see this part. Let me make it a little bit bigger. We use full screen mode. No, this is not good. Maybe this one is a little bit better. Okay. One of the example is right here. So you guys maybe learn some. Did you guys begin to learn physics, electric physics in middle school? Not yet, right? You guys didn't learn this part yet. You know the resistor, inductor, and capacitor. Nope. Maybe you guys didn't really learn this part yet. This is maybe needed you guys go to high school or the last year of your middle school. You will learn this part about resistor, inductor, and capacitor. So if you guys didn't learn this one, take a little bit longer time to explain from the beginning concept, a basic part to go here. I mean, we maybe learn this one a little bit later. So complex numbers, we stop here. So you guys just do your homework and we will check homework a little bit more from homework next week. Okay, because a complex number basically is the same as it's very similar to the polynomial part. Okay, yeah, here they talked about when you use the smartphone, when you prepare a smartphone to the electric board, they need to use that information. Why we use these kinds of electric conductor, capacitor information. All right, so what's today's topic? Actually, I still miss one of them. So when we do the complex number, when we say absolute z, actually is try to find out what's the distance between the dot and the initial number. Let me go back to share this one right here. We're still talking about the one about a complex number, find the absolute distance. Something like say 3 plus 4i. Absolute value actually is the distance from the dot, from this dot to the initial number 0 0. So we know this number is the 3 and 4, right? So we can use the right angle right triangle methods. So here is 3, and here is the 4, and this side is 3 square plus 4 square, and square root of the result. So 3 square plus 4 square equal 25, right? So square root here is 5. So you can see, yeah, exactly use this kinds of progress. So I know this one talk a little bit quicker because we talked this one last week already, right? Another examples, say -4 plus 2i, -4 plus 2i. Actually, so the size of this right triangle, right? And it's one of the size 2, the other side is 4. So 2 square plus 4 square actually is 20. So this side will be square root 20. Right? Square root 20 equal 2 square root 5. So that's it. Relative fun, huh? Did you guys understand? Have any questions about this part? We'll quickly review last week. What are we talking about? Complex. Conway?
Yeah.
Yeah, you do? Okay, great. Yeah. Laila? Yeah, you don't answer yet. I didn't hear you. What about you, Mason? Mason, did you? Okay. Tony?
Yeah.
Ryan, your mom say you didn't answer, a lot of them was not well understanding. Did you understand what are we talking right now, Ryan? Angela? Ryan? I know you guys hide behind the screen, didn't answer me, so I cannot do anything. So if you guys have question, all right, talk it out, okay? Angela, Jane, Angela.
Yeah.
You do, good, good. Michelle.
Yeah.
Okay, all right. So today we just move to a little bit, okay, before I move to that one, I should go back to review some homework. Earlier, what we left behind for the week 5 and week 6. Let me go to the week 5. About this one. Did you guys do this homework before? Have you did it? Anyone get the answers for this one? Week 5 homework. I know this is.
No, I got stuck.
Okay, let's do this together, okay? Okay, this is the week before last week. I think Ian studied and someone else also asked this question as well. Try to understand what's going on here. Let's see. All right, let's see, quick. Let's do this one together, this part. Firstly, before we do this part, let's do one step by one step, okay? So did you guys have function fx equal here? We just list one rewrite, right? Let's go back to review. This one rewrite we can like this, right? When we do the graphing, we know this one, we can graphing this one, x minus 1. We can graphing into what? X minus 1. When x equals 1 equals 0, right? -1 is, when x is 0 is -1. It's slightly, we can graph like this. It's x minus 1, right? When we do the absolute means the one below the 0 part became opposite, right? It became positive. So the part of this was cleared. This part, we don't need this part, right? Because it's -0. So what actually we use is this part. Right? So here is 1, 0. So when y When someone give this kind of question, y equal x minus 1, what this means? So it means give any x minus 1 is this distance, right? The distance of right here. The distance of right here, x minus 1 is distance of right here. And equals, this one is also x minus 1 because of the slope of here is 1, right? So this part and this part is the same. So what this means? What this means? This means if it means here x 0, give any number x, this one x minus 1. This means the distance from the point to the 1, 0, to the 1. Something like x is 5. So x is 5, 0. You give it x 5. The distance to the 1 here is 4, right? So x minus 1, this means any number from here to here. What's the distance from this dot to here? So x minus 1 is this means. So any number, the dot area to the 1, 0, to the 1 spot, the distance. So we understanding right here is if you give any dots to the distance of 1, to the distance of 1. So here means this part is the distance of from the number, any given dot to the distance of 1, 0. Any distance to the 1, 0. Okay. So something like give any number here. The distance to here to the 0 is right this part. Actually, we give its value became into the y. Right? This part and this part is the same. So the objective of this one is say the distance from to the dot 1, and give you any x to the dot 1. All right. So if there are 2 of them, what can we do like this one? What we actually it means? So it means what? Means x minus 1. Right now this one will rewrite into what? We write into x minus half. 2 of them, right? We write it into 2 of them. So it means what? It means if you give you a dot is 0, and this is 1, and this is half, give any dot. So you need to the distance to here plus the distance to the here, and plus 2 of the distance of here, right? So any dot to here, to here, to here. So this distance plus this distance. All right. So that's 2 distance passed together. So if there's 2 dots, what the distance most small is actually in between, right? Which one is the became the most small to them? So if you any dot from the right part, you need this distance plus distance, right? If the dot is exactly on itself or the 1, if the dot is exactly on the 1, the distance to the 1 became 0. The distance to here became half, right? Just like you're saying the distance from this part to the 1. Let me change a different color to explain this one right now. So if you give the distance, the dot is right here. The distance from here is this part. And distance from here is this part. So you needed to, something like suppose we here still give the 5. The distance to the 1 is 4. The distance to the half is 4.5. Right? So if you give the 5 here, here is the 4, right? Plus 2 times 4.5. So totally would be what? Totally be this is 9, this is 4, It became 13. So it's a very big number, very big number. So so this one, the further go to this way, this number the bigger, right? So they want to find the smallest number. What's the smallest number can be? So just like, let me zoom in here a little bit inside. Zoom in here is 1, here is higher. So if you pick a number, the dot is actually inside. The distance to here and distance to here is always this distance, right? Suppose here distance from here to here is always the same. If you pick the right side of these two dots, the distance is this part plus this side. Definitely is bigger than this number, right? This distance plus this distance, definitely bigger than this distance. So any dot in the right side of this part, the distance you got here plus got here, definitely bigger than this distance. So you don't like this one. Don't like any dot this one. When you try to find a small number, you find the dots actually in between, inside, right? Okay. So when you find out this one, so what number can make this be so smallest? We need to find a number in between here. Okay, in between number here. So actually, so you guys can see. So you guys can see. Let me erase this part first. Erase this part first. All right, erase this part first. So this one we can rewrite this one. Absolute, right? You can rewrite x minus 2 plus x, right, like this. So this one became 3 distance. So give you a spot, 3 distance, twice 3 distance, something like you say. I still make a big drawing. Here is x, and here is 0, here is half, and here is 1. All right. So this one means any spot, the distance to the 1. So if I pick any dot is right here, the distance is this part. But at the same time, what's the distance to the half is right here. And listen to this part, also here, right? So it means 2 times of here plus time here. So the distance actually is this part plus 2 times of this part. How they became more smallest? So if this way move closer to this part, let me use this part. You move closer this part. The distance here became smaller, right? And distance here became bigger. So right now you need 2 times of this distance, 2 times this part, and 1 time this part. This part distance plus this distance is the same, always the same, is half. But they add another this part. So the one you move this to this side means all of them became bigger, right? So if you move this distance to the left part, and the distance will become into something move to right here. So this is 1, and this is 1, and plus this one. So this part plus this one always is half, but additional is this one. So if you move more closer to here, to the half, the distance is this one and nothing, right? So when x equal half, this data is the least, the minimum, so equal 1. Because when you got a half, no, I'm sorry, not half, only this half, because this half, only the distance here. When this one is move closer to finally to move here, and this part became 0, and this part became 0, and this part is always distance from here, right? It's half. So here is the minimum. So it means x equal half. This one, the function will become the least distance. The least distance. Right now, when we expand it, so it means more close to the median one. So this is 1, and this is 1, and this is the median, right? So more close to median, their result is the least, the minimum one. So right now we go back to see this one question here, this question here. So let's actually make a lot of different distance. I know this one expanded a lot. Let me expand a little bit here. We didn't go too far, all right? We didn't go too far. So this one we can rewrite it into like this one, like what are they doing here? Actually, I just rewrite it one more time. So 2, we take this 2 out. This means rewrite amount. That's what we right now talking. So what about another number here? Actually 3x minus 1, right? So 3x minus 1, we just say 3x minus 3 half. And 1/3. So x minus 1/3. X minus 1/3, right? 3 times of them is this part. Because of this part, can transfer into 3 times x minus 1/3. So I just rewrite it into here, right? So what's the minimum of this part? So what's the minimum of this part? So this is the biggest, second biggest, third biggest, and this is the most minimum one. What's the median of the one? Median one is this one, right? We put this the biggest, second biggest, the third biggest, and then this is the smallest, and less smallest. Actually, these 3 is the same. This is just like numbers. Next may say 1/2, just like you have different numbers, 1 number, 2 number, 3 number, and the least, the biggest to the smallest, right? This is the biggest, and this is the smallest. And we find the median number. Median number is right here, right? And median number is right here. So middle of this median number, middle of this median number is half plus 1/3 and over 2, right? So you can got the median of the number is 5/6 and divided 2, right? So it's 5/12. So actually the objective is to find the median number. Objective of the median number, okay? All right, so how many number totally here? That's a lot, right? Because of here has 1 number, here has 2 number, and here, and right now just we say here have 3 number. What about this number? Here have 211 numbers. So how many total here? How many total number they have? How many total number they have? It's a lot, right? So how many total number is first number plus last number divided 2 times 211. Right, so many numbers. So what's the middle of this number? So that's what are they doing here? Exactly what are they drawing here? I know you guys maybe right now a little bit confusing. Why have there so many numbers? Why have so many numbers? Yeah, so many numbers. Yes. There are too much number here, right? So here actually is so many. So how many number here totally? How many number totally here? That's a lot. Here is a 212 over 2 times 211. That's too big a number. I know this number is crazy. 1006 times 211. Okay, so many number. What's the middle number? So many number. Middle number is half of length, right? Half of length would be right this one. This number, that's what the exactly talking about. Okay, this is number. So which this number would be? So this number would be the middle of the number. The middle number would be, where is it? We need to find out what's this number. So this number would be just like say, if it's 1 over 3 times over 11. So this is the middle number is from beginning. You needed to say here is 1, has 2 and 3. So you need to find which of the middle number in between so many number. Totally number over here is too big, huge number. It's crazy. I actually is too so big number. I know this right now, making you guys maybe don't understanding what's going on. What the teacher talking about here? Too crazy. I know this is Olympic math competition question to here. I leave this question up to now here. Let you guys, let your parents help you to do the rest. I know this is a little bit crazy because when I was explaining this one, I don't know how many you guys can understand. This maybe would have become a topic for whole classes. So we just stop here. I just make you guys know the middle, how many number, total number in between here need to plus together. So we need to find the median number. You guys maybe didn't learn the median number yet, but finally the median number should be this one. And we find out this median number. We need to find out this median number. And the median number, what's the fraction would be. And so if you put this fraction inside, you got the answers. So find the median number. That's the median number come from, okay? All right, let me see. Another question at the homework. That's the median number, what do we have? Another homework, let's move on to next questions. Do we need to take a time break? Everyone, do we need to take a time break?
Yes.
Really? Did you guys understand what are we talking about now?
Kind of.
No. I know kind of take a little bit longer time to explain this one. For this question.
I just didn't get the Olympic math thing.
Yeah, this part I put it right here. Because this one take a little bit longer to explanation. This is really an Olympic competition question. I actually initially give you guys, try to give you guys a thought, which you guys can think about what this means and how do this one. Because we introducing the absolute value. We're introducing the absolute value, right? So we need to find out how it's normally used in our real life. So it means a distance, just like the dot to the 1, it means the distance. So when the distance became bigger, the multi-distance plus together, you find the shortest distance when you travel. When I expanded the crazy kinds of situation. But now this one is happened in 2015 Olympic game. They use these kinds of question and they exactly use our basic information about absolute. So, okay. So let's stop here. Don't worry about this one. I know this is a little bit crazy. I know you guys, if you really need good at this one, take a little bit longer time to practice this part. So take a, what about take a 9 minutes break, come back 3:55. All right, and then we begin the new topics. All right, talk to you a little bit later. So this method we describe here is the homework part. I know this part a little bit challenging. I know, yeah, so that's why we say when graphing and is a very useful method to basically evaluate how much what solutions. A little bit later, right, Brian? Sorry.
I did quiet.
But not now. Daddy have to stay here, finish topic, but only 15 minutes, 15 more minutes, almost done, okay? All right, thank you, Brian. Okay. All right, that's the homework part. I know we spend a lot of time to do this one, but it's worth because of there's a question there. We still need to spend some time talk, make sure everyone can understand. Okay. Anyone have question to this part? I didn't hear any answers, so I think maybe a lot of questions in the back part of here. But let's spend some more time to digest and come back to review it. And maybe go to, when you guys next year go to the Algebra 2, most of the question will be like this, a little bit challenging.
Can not get a sticker.
All right, sorry, let's move to the new topic now. All right, so today we move to some new topics. Actually, not new, not totally new, actually. In last several weeks, when we teach about, say, functions, I actually didn't spend especially talking about functions. This is special part. I mean, when we talked about, say, right now, just like we say fx, I didn't specifically talk about what it is. This is talking about function. And actually, you don't make it so confusing. Like this one, okay? Like this one. When we do the linear line, we say y equal x plus 6. Actually, this one, we can also describe this one, say, we can also, this one say fx equal x plus 6. The same description. We just change the y into f, like describe it like this. So that's no big difference from this part, right? Because we say y, we replace with this one. And then say when you input, because right now here you describe input, and you got something like say input x, you can got x plus 6. So when we do the table, say x, y, right? When we input is 1 and come out is 6, 7, x plus 1. So looks like you input x and go through something magic kind of transform and you output y, right? So input 1 and you actually do this kinds of calculation and come out is 7. Later, please. Thank you, Brian. Give me one, please. I'm behavior good today. All right, so if your input is 2, and you 2 plus 6, do some these magic kinds of box transform, So your output is 8. Okay, so this is means just like a transform. So when you input, they come out 1. When you input and come out 1, right? This is called function. So let's see, go back to see what's doing here. I'm doing here. All right, so something like y in y plus 6. When we do the linear graphing, will be like this. Thank you. So you input any numbers, x numbers come out relative only 1 numbers. Okay. Something like you input a -2, you got a 4, right? You input a -6, comes 0. So this is the function. So this is the function. You can just replace that one with fx, right? So anytime you input x equal x plus 6. So you say f, someone give this kinds of formula for you. So I right now want to input fx is -2. You just need to replace this x2, right? So you can got here, got a 4, right? Okay, so if you input is -6, so actually it's -6 plus 6. So your output is 0, right? So you input 1, you generate 1 data. You input 1, generate 1 data, right? So x can be any number from negative infinity to positive infinity, right? Right. So when you can generate y, and can be any number between here, right? So because of the range, so we call this one is the domain. This is the domain. Domain is what x can be possibly picked from, and what the range means what y possibly in area. We call this is range. Okay, this is called range. This is range, and this is the domain. Domain means x possibly area they can pick. Y means all, the range means all possibly y combinations. Okay, the same to here. Same here. Let's say this one. Y we earlier learned quadratics. So actually, so this one we can replace by 1. We can replace the fx like this one. So here became x squared minus 3. So someone gonna say 1 to the y of 0. Give this formulation already. So it's 0 squared minus 3, right? Output is -3. So any number you can put input. So x can be just like we say from negative infinity to positive infinity. So they generated these parabola curves, right? Like this. All right. So let's see. So when we see this one, so you can see x can be, sorry. So x can be what? Negative infinity, right? Any number from negative infinity to positive infinity. Your input can be any number, there's no limitation. But what about y? We can see the minimum of this y actually right now is what? -3, right? And what about the top part? Top part can possibly extend a lot, right? It takes a lot. It became positive infinity. So that's why the domain means x possibly pick range. The domain is x pick range. It can be negative infinity to positive infinity. What about range? Range means y possibly area. So right now you can see they are less than -3. They are not exist, right? Let's know given any numbers, you didn't have find any number less than negative infinity here. This part, this part is didn't find. So actually the range is minimum is -3 to positive infinity, right? So range will be this. and domain will be this. All right. So what are we learning up to now? Most of focus on the linear line. Linear line, like linear line, actually the range is pretty broad. If there are no limitations, described limitations, so you can go say negative infinity to positive infinity for the domain. And y, the range also is from negative infinity to the positive infinity, right? If they just don't describe limitation of x, so the y is pretty broad, because this one just like cross, this linear line is pretty broad crossing from beginning to the lowest to the negative infinity to the positive infinity. That's a pretty broad range, and x is the same. But for the polar quadratic is one. Right now, if the mouth is open up, they have the minimum value. When the mouth open down, they have a maximum value. So the range was limitation right now. Right? Okay, so we describe here is say a function. They are domain and they are range. But we need to be very clear. Let's each time, when we input one data, just like input at one x, they generate only one y, right? We input one x, something like say -3. Here they just input only one y. Input 3, input one y, right? Just like each input data, just output one data. Okay, let's call function. If you input one data, generated two data, that's not good. Let me give one example here. Let me give one example. All right, let's see here. Okay, let me give one example here. So something like this one. If you input one data, they generate only one y, right? So each one have you one, because of each generate anything. You just generate any, put any y. They only have one y. The same here. You put it one x, generate one y. Generate one x, generate one y. Okay, so this is called function. But what about this one? When you input one x, they possibly have two y, right? You put one x, they generate two data. That's not good. So this is function, this is function, but like this one, you input one x. Oh, Bradley, I cannot give you control. So they generate two one. So this is non-function, okay? Because you input one, generated two y's. So it's not good. What about this one? You input one x, you have multi-y, right? A lot of y, a lot of y. So this is not function, okay? All right, that's the basic information we need to be clear is one put x, just output is only one y. If you multi-y, this is one y. See, only input one x, generate in y, just only one data. So this is function, this is function, this is non-function, this is non-function because the input one y is not acceptable. I mean, it's multi-y output, that's not function. So that's the basic thing we need to explain more clear. Why, when it's function, when it's non-function. Okay, let's go to next a little bit, some more information here. So my homework in this part today, maybe will be ask you guys to say, find graphing this function and find the domain and the range, just like talked about when we do the linear line, x is negative infinity to positive infinity. And but when we graphing like this, with graphing with the like what do we say, with the absolute value, like this one. Okay, so right now it's a little bit different, right? When we do the graphing like this one, initially x minus 4, like absolute x is like this, right? This part. So minus 4 is became here. So it's became here. So suppose like this kind of, so here is x, when the x greater than 6 is right here, and x less than 0 will be right here, right? So minimum value is right here. So you, for the domain x, you can negative infinity to positive infinity. But what's the minimum value of this for the range? What about for the range? The minimum value is -4, right? Here is -4 and above. So for the domain here is -4, the including -4, and positive infinity, right? Because it's the y value is only this part in between here. So nothing value is less than here. All right. So that's the part of what we talked about graphing and function. We want to talk about a little bit more here because we never mentioned about domain and range and what's the concept of function. So that's all for today, I think. And I will send this out as our homework. Not too much, just 6 topics, all right? 6 questions. So see you next week. Have a wonderful day. A good one.
I had a question.
Yep, louder, please.
Could my dad emailed you, and I was wondering if you could give us the answer key for the questions 1 through 5.
Yes, I can do that and say now.
Okay, thank you very much.
No problem, yeah.
Thank you.
Yeah, all right. Talk to you later.
Bye.
Bye.
Bye, have a good day, everyone.
Bye.